we will start with chapter 1. In chapter 1, we will look into general terms in statistics. This is what will set the base for the later chapters. We start with what is statistics, where you have to know that statistics is the process of collecting, analyzing, presenting the data, which can be used for inferences, to make inferences for specific decision making. We have two main branches in statistics. We have the descriptive statistics and we have the inferential statistics. Under descriptive statistics, we have everything that we use to summarize and display our data. Well, under inferential statistics are basically the statements, the conclusions made for the population based on sample data from the population. Now, a population represents all possible outcomes of measurements of interest, while the sample is a subset of the population. We have two data sets. We have the population and we have the sample. Population are all outcomes that are of interest to us. This is what I wanted to highlight, while a sample is a subset of the population. What do we need to remember? That measurements that derive from a population, which are called population parameters, we use Greek letters to present them, while measurements that come from a sample, we use Latin letters to present them, and they're called sample statistics. Elements are the entities on which data are collected. Variables are the characteristic of interest for the elements. The set of measurements collected for a particular element is called an observation. You will have one observation per element. So let's look at this example. Parking at a large university has become a very big problem. University administrators are interested in determining the average parking time of its students. An administrator followed 170 students and carefully recorded their parking times, identify what is the population and what is the sample of interest. Obviously, the population will be the entire set of students that park at the university, while the sample is the information that we have collected from the 170 students followed by the administrator. As mentioned before, a parameter is the data that describe characteristics of the population, while a statistic is data that describe characteristics about a sample. We use Greek letters for the parameters, we use Latin letters for the statistics. Determine whether the underlying value is a parameter or a statistic. Whenever you have a question like this, the first thing you need to do is identify if the information came from a population or a sample. A study of 2,100 college students in a certain city found that 4% had been victims of violent crimes. This is based on a study of 2,100 college students, which is your sample. Therefore, the information is a statistic. Now, data are the foundation for the field of statistics, as you probably already know. Is defined as the values assigned to specific observations or measurement. Information is derived from data for the purpose of making decisions. Data sources are either primary or secondary. Secondary data sources are collected by someone else. You're basically borrowing information already collected by someone else. Primary data sources are data that you have collected for your own use through direct observation, experimentation, or surveys. Now, in an experiment, subjects are exposed to certain treatments and data of interest are recorded. A survey involves directly asking subjects a series of questions. Now, data can be classified as quantitative or qualitative. It's very, very important to understand the difference between the two. Quantitative data is data that uses numerical values to describe something of interest, is always numeric. Qualitative data, characterized by terms describing the data or use descriptive terms to measure or classify something of interest. What we need to remember is that qualitative data can be either numeric or non-numeric at cases. So non-numeric, I believe it's obvious, anything that you use to characterize and present the information. Now, numeric data that is considered qualitative is anything that has to do with codes. When we use codes, for example, female 1, male 2. So whenever you see the ones and the twos, let's say in a survey, that does not mean that this is quantitative data. It's qualitative data presented by numbers to make, for example, entering the information a lot easier. Let's look at the examples. Classify the variable as qualitative or quantitative. The number of calls received at a company's help desk. Number of calls. This is quantitative. Classify the variable as qualitative or quantitative. The native language of students in an English class. This would be the native language is non-numeric, and it's going to be qualitative. It's a descriptive term. Now, a further distinction among quantitative data. Quantitative data can either be discrete or continuous. When we talk about discrete data, we talk about countable values, integers, while continuous can be any value in an interval or collection of intervals. That means you can have integers and non-integers. Determine whether the quantitative variable is discrete or continuous. The number of bottles of juice sold in a cafeteria during lunch. The number of bottles, you would say how many, a specific count. Therefore, the quantitative variable will be discrete. As far as the scale of measurement goes, data can be classified as nominal, ordinal, interval, and ratio. When you have qualitative data, the scale of measurement will either be nominal or ordinal. When you have quantitative data, the scale of measurement used is either interval or ratio. Nominal level of measurement deals strictly with qualitative data. We simply state the different categories. There is no meaning in the classification how the data is presented. Ordinal level data have all the properties of data measures at the nominal level, but we can rank order the values from highest to lowest. That means under ordinal, just like the name states, order is important. There is a meaning behind the classification of your entries, your variables. Now, interval ratio, quantitative data, interval level of measurement, the differences between the data can be measured with actual numbers, giving measurable meaning to the difference. And ratio, data have all the properties of the interval data along with a true 0 point. A zero data value indicates the absence of the object being measured. Under interval, you will find scales that we have created, and you may also have negative values. So when we talk, for example, for temperature, right? Temperature is a scale that we have created. When we say that we have 0 degrees Fahrenheit, does that mean that we have no temperature? No, it simply states that 0 is a point on a scale. Therefore, it falls under interval. Ratio, on the other hand, you cannot have negative values, and when you have 0, it means absence of an event. So let's look at the example. Determine the level of measurement of the variable, the medal received, gold, silver, bronze, by an Olympic gymnast. The first thing you do is determine if this variable is qualitative or quantitative. The medal received, that would be qualitative. Under qualitative, the options are nominal or ordinal. So, is order important? Yes. Therefore, the classification is ordinal. The scale of measurement is ordinal. Determine the level of measurement of the variable weight of rice bought by a customer. The weight is quantitative. Does 0 mean absence of an event? Yes. Therefore, it is ratio. In addition to the notes, you will also find objectives under chapter 1 and key terms. Make sure that you go through all the main terms used in this chapter before you move on to the problems and examples. So these are the notes for chapter 1.